Morning students. Today in this session I want to complete experiment number 1. So in this class we are going to design DCC and lab part B experiment number 1. So aim, all of you write aim, implement a point to point network with 4 nodes and duplex links between them and analyze the network performance by setting the queue size and varying the bandwidth. So we can vary both the things. So we will see one by one later. The tools already we installed previous session. Excuse me. The tools required are NS2 and NSG 2.1 simulator and network animator and Java development kit is required. So otherwise simple Java, you install simple Java because we are using NSG 2.1 jar. So once this is done, now I am going to open the terminal. So here Control Alt T, so that opens the terminal. So I want to create one folder, so someplace. So CD, change directory to desktop. Previously we created a folder on desktop that is nothing but DCC and lab. So in that CD space DCC and lab. Done. So once you are in the DCC and lab, just I already one more folder created, that is experiment number 1. Okay, CD space exp1. So this is the path, the total path is, so on desktop DCC and lab, in that there is a folder called exp1 or directory. Generally it is called directory in CLI. Now I want to open my scenario, Java space jar space Java space -jar space NSG all capital 2.1 dot jar. So already we installed this thing. So must and should here we need to do when we are creating these type of things. So where is the jar file? So on that path only you must and should. So this wantedly I am showing here. So people are getting error at this place. So at that instant, so I want to go one time back. That means what? In DCC and lab it is there. So NSG 2.1 is there in a DCC. This already previously we copied. Okay. So that's why it is unable to access. So that's why first you need to do path correctly, then hit enter. So now scenario is opened for us. So once scenario opened, then click on, there are 2 variations are there. One is wired scenario and one is wireless scenario. So I am taking wired scenario. Okay. So wired scenario. So click on node. So node 0, node 1, total 4 nodes we need to take, node 2 and node 3. So according to our problem statement we are taking total 4 nodes, and after that we have some link. So you know the simplex and the duplex links. Yes. So now I am selecting duplex links between the nodes. Okay, just hit on that thing, automatically it will collect. So here the drop tile and the capacity is 100 Mbps and propagation delay 10 milliseconds and the queue size is 50. I am not changing anything, default what is coming, same thing I am. Next, so here I want to select my agent. So my agent is TCP. So from which node to which node I want to transfer the data, I need to select here by using certain agent. So here my agent is TCP. So I am selecting TCP protocol. So TCP, and here also TCP. So like this I selected. So once you selected this thing, must and should where we are selecting our destination, at that moment we need to put TCP sync also. Okay, TCP sync, and here also TCP sync. So just click on this node and this node, automatically they will collect. So this is nothing but what? The agent we are using, which type of protocol we are using, that is connected properly here. Once this connection done, then select the application. Here if you want, you can change the packet size and everything, but I am same thing I am using. And here if it is a TCP agent, must and should need to select FTP, file transfer protocol, or otherwise if it is a UDP you selected as a agent. So previously if we select UDP as a agent, null must and should be the sync, and the application must and should be the CBR. Okay, that is only the change. So remaining all are same. So next FTP 0 and FTP 1, both the sources are FTP only. So applications are done. Next, where you want to stop, there is nothing but where is the stop time. So the stop time I want to use 8. Okay, so otherwise we can change later also, so no problem. So next, the parameters. So any parameter change, the total simulation time is 10 milliseconds, and trace file name is out.tr. So this is only our requirement. Okay, so nam file name is out.nam. So default only I am using. So because every experiment I want to do in a separate folder or separate directory, so then I don't want to use anything. Okay, save as default. That one is a default thing. So then once this is completed, here the tool command language. So actually we need to write this language. So we are unable to, with respect to time limitations and everything, we are unable to write the TCL properly. So maybe somewhat hard also. So that's why we are generating TCL from scenario. Directly we draw a visualization, network visualization or network simulator. By using that simulator, we created TCL. So if we click on that thing, automatically the tool command language is opened like this. So the program, actually we need to write this program, and every line is explained like this thing. So NS2 is a visualizer, and NS2 is a good simulator for networks. So you can implement TCP, ADP, UDP and everything. So some protocols also we can implement and visualize the networks. So for that, in research orientation, people are using lot of times this thing. So now here we are offering these things. So where it is going to start? At start time is 1 and stop time is 8. I want to make this one as 8. So this is only I want to change. So next, I don't want to change anything at this moment. So later we will change the bandwidth. So from link 0, that is nothing but node 0 to node 2 is nothing but 100 Mbps, and the queue size is 50. So then N1 to N2 is 100 MB, as well as the node is 50. So all are default same thing. So next time I want to change this thing. Okay, at present I don't want to do anything. So save. So where I want to save means, so in my folder, in my working directory, in my experiment 1 I want to save. So that is experiment1.tcl. My file name is experiment1.tcl. Just I changed only the timing. So the stop time only I changed. That's it. So just I want to minimize this thing, and now I want to execute that thing. So I want to execute that file, and I want to see the result. So visualize the what is the network doing. So for that, just I want to open one more terminal. So here cd space, so desktop. So then next one more thing is required, that is cd space exp, sorry, cd space dccn lab. So then cd space exp1. So once you are at the path, so you need to type ns space. So what is our file name? exp1.tcl. So this is the command. So when you are using or when you are run your TCL file on NAM. Okay, so once you type this thing, so it will open in network animator. Previously we installed this thing also. So now this is the NAM and this is showing our network. So just hit on this thing. So at 1, so the time at 1 it will shows the data flowing, because we started at 1. After 1 millisecond only we started, so that's why. See, so if you want to increase the speed also you can increase. So the data is moving and acknowledgements are coming back. So we can see the network is how the network is working. So how the data is firing from node 1 and node 2. Okay, so here 3 is the receiver, node 3, and via 2 the data is moving. So this is only you need to observe. So if you don't want to wait so much time, so you can increase the speed also. So then data is moving very fastly, and our time, so you can reduce the time also. So data is moving and acknowledgements are coming back. So that is the scenario. So that means what? We are able to create or implement a point-to-point network with 4 nodes, and we are able to visualize the network. Okay, done. So the part 1 is done. Now I want to go to my folder, so my work directory. So that where is this one? So when I do execution of that thing, I got 2 things. One is out.nam. So by using this out.nam only we executed that program. So we saw already this output. And out.tr. If I open this out.tr by using any text editor, so this is the out.tr. So what is this exactly? So the trace file, you need to trace. So whenever we are doing some kind of experiments in any type of lab, so we need to trace the output and point by point. So here there are some scenario is required to study this thing. So I am giving that thing in a out.tr file. So first thing, the event, the first bit. So event indicated maybe R or plus or minus or D. Okay, there are only 4 chances are there. One is R, one is plus, one is minus, one is D. So out of these 4, R means receive, plus means NQ, minus means DQ, D means drop. Okay, so these all are at node, at 2 node. So receive at 2 node, and here at Q. So NQ and DQ are respective of Q. So sometimes it is dropped from the Q. So this is first field is telling like that. Next second field is at 1 second and 0.3556. So that is nothing but time, the time at that moment. Next from node. So this is from which node we are talking. So the second one is 2 node. So this one is 2 node. The fourth field is 2 node. Fifth field is acknowledgement. Sixth field is the number of bytes, that is nothing but the packet size. Okay, the number of bytes in the packet, that is called packet size. And these all are indicating the flags. So in TCP you have some flags, urgent flag and everything. So that flags are indicated here. Next, FID. So here we are using certain FID, and source address. So we are not using any source address here, and destination address, and sequence number, packet ID. So these are the things we need to find in a out.tr. Okay, so this is about out.tr. So with respect to this thing, so we are unable to count these things. See, so this is a big file. So around 40-50 pages it is there. So these many lines we are not going to verify ourselves. So for that we need to write a script. So we need to write a scripting language here. So AWK. So AWK script is as like HTML how we are using for web development. So for analyzing or for study any text file or anything, or data visualization purpose and data accounting purpose, we are going to use AWK is the scripting language, a high level scripting language for data analytics. So then I want to write a program. So it is as like it resembles maximum times as like a MATLAB and everything. So see here begin. So I am declaring 4 variables: count 1, count 2, count 3, count 4. So this is also required, sir. So we need to write this thing. So if $1, that is nothing but first field in the out.tr, first field in the out.tr is equal to R, that is event is receive. So next second field I am talking about. So here fourth field is, that is receiver. So we are talking about the receiver. So whether it is received at 3, and what is the protocol you are using? TCP is my protocol and agent. This is next to what is the size of the packet? So 1540. Okay, 1540 is the size of the packet. So if these conditions are satisfied, that means we are studying that out.tr file. So you need to increase count, okay, count plus plus. Okay, then same way here, how many dropped? Where? At source, that is nothing but 2. At source node 2, how many packets are dropped? So same agent is TCP and this one is bit size, or how many bytes in our packet. Next count 2 plus plus. So next same way here, how many bits sent by our node 0? Okay, so our node 0 plus, that is nothing but NQ and DQ. So we are talking about NQ, how many are from node 0. Okay, so same here also. So that is increased here. And how many are from node 1? Okay, because from node 0 how many are coming, from node 1 how many are coming. So totally matched or not, we need to find that thing also. So finally after studying that out.tr, I need to print the result. So total number of data packets sent by, so node 0, total number of data packets sent by node 1. So then total number of packets received at node 3. So then total number of packets dropped at node 2. So that means we can easily visualize our entire out.tr file. Okay, so for that purpose, so we need to write this ex1.awk. Okay, you need to write, so there is no option, so it doesn't created by any software. Okay, so then open the thing. So once you open that scenario, so just to close all these things, these are not required for us. So now we are at the experiment 1 only. Now I want to type that this command awk space -f. -f means the file name. We need to give the file name of the awk file. So ex1.awk, because experiment 1 I wrote ex1.awk. So which file I want to use for that? As a input I want to use out.tr. Okay, out.tr. In C also we are giving this, the command line arguments. When you are giving like this only you need to give. Yes, same here also. So awk is the type of scripting language, and we are giving certain files. So ex1.awk, that is our destination file, so where you want to execute. And next one more thing is out.tr is nothing but our input file. Okay, so for that command execution. So once you hit on this thing, so automatically you got this results. So the total number of data packet sent by node 0, okay, 3410. So then same node 1 also 3410. And if you increase or decrease the size of the bandwidth and everything, we can easily find the difference between the node 0 and node 1 also. So and same total received, so 6820. So that means yes, it is correct. There is no drop, there is no lose. So that is losing of any data. So now once you got this thing, so once again I want to go to my file, TCL file. So first visualization completed. The first results what you got. Two things we observed. One is by using NAM we observed visualization of data packets, how we are moving, how they are moving from node 0 and node 1 to node 3. So next we observed the analysis, the data analysis, how it is moving the packets. Okay, so which one is creating how many packets and how it is moving. So now I want to change some changes here, because I need to study the bandwidth changes and everything. So for that, so here I want to change this one as 50 is my bandwidth. Okay, node 0 is 50 and the queue size is maybe 30. So then the second one I don't want to change. From node 1 I don't want to change anything. So from third one, so here I want to change this one as a 10 and this one as 4, 10 Mbps and 4. So if I change the bandwidth as well as the queue size, what happened? So save. So once again I need to save this TCL. So already it is saved exp1.tcl. So once again just hit on save. So now I need to run same commands. First I need to execute this thing and hit on execution bar and just somewhat increase the speed. So data is just dropping, see, so some packets are dropping. We can easily visualize that thing. Some packets are dropping. So this is the thing what you need to observe. So when the data is moving, some of the packets are going to be dropped. Yes, like that. Okay, so you run entire thing up to 8 seconds. So then, so if you want to increase the speed, you can increase. So like this. So some data is missed or some packets are missed because of we changed the queue size and bandwidth. So then, so once it is done, then once again run this file. See, so the total number of packets sent by node 0, 1496. So this time, because so there is a change in the bandwidth and that thing. So node 0 and node 1 also separately they are firing packets separately. Yes, they are giving input packets so differently. So 1496 only given by node 0, 1569 is given by node 1, and the number of packets received at node 3, so that is 3032, and the number of packets dropped at node 2 are 33. Okay, so we studied about these things. Okay, so when you change the bandwidth and everything, so this is, so same thing you need to repeat by using UDP also, by using UDP also. So by using UDP means simply here you need to change. So instead of a TCP agent, we need to put FD agent. So UDP agent and null as a sink. And same way the packet size 1000. So we need to make this thing as a 1000. And the next application we need to select as CBR. So same thing we need to observe. So at that instant also we can change the queue size and bandwidth. So whether it is depends upon the queue size and bandwidth or not, we can visualize. So this is the end of the experiment 1. So simple. So the experiment is very simple. So as compared to remaining, so remaining are somewhat hard. Okay. So then this one is the output. So what I generated. So first one. So with a bandwidth of 100 Mbps and queue size 50. So the next one, the bandwidth of 110 Mbps and queue size 4. So then some packets are dropped, so I got this result. Okay, so this is the conclusion. So we did this experiment. We implemented a 4-point network, and by using some changes, that is queue size and varying the bandwidth, we studied the network, as well as we need to implement TCP as agent and UDP as a agent. Done. So this experiment is completed. Thank you. So next week we will see experiment number 2.